Hello guys, today I will be explaining the solution of Cubo and Primes. So here's the problem. Cubo is just learned about prime numbers and comes across an interesting problem. Cubo is given a number n and has to find the sum of primes present as digits of this number. Can you help Cubo with this problem? So the input format is the first line of input contains integer t denoting the number of test cases. The next three lines contains an integer n. Output: for each test case, print a single integer denoting the sum of primes present as digits. So they will give us a number and we need to check each digit, and if it is a prime number we need to add the sum and return the sum. That's the question. So the constraints is given as t can be between 1 and 50 and n can be between 2 and 50,000. So that's all. Here's the sample test case. So there are two test cases and one is given as 333. So all of them are prime, right? So we need to add them. That's 3 plus 3 plus 3, that's equals 9, and that's the first output. And the second output is 686. None of them are prime, so we need to add nothing. So that's the output is 0. So now I will explain the solution of this problem. So these are the given inputs. The number of test cases t, and the next t lines contains integer n. So this is the algorithm for one test case for each number. So n equal to input, that's an integer, and we initialize another integer sum equals 0. And while n greater than 0, we do this. X is equal to n mod 10. We use n mod 10 because when we do that, we'll be getting the remainder after dividing by 10. So that will be the last digit of the number. So this is a trick we use to get the last digit of the given n. So x will be having the last digit, and we will be checking if x is equal to any of these four numbers, 2, 3, 5 or 7, because there are only four digits which are prime. That's these four. So if x is equal to any of these, we add that to the sum, and then we need to get rid of that digit. So we divide n by 10. Since n is an integer, when we divide it by 10, and we won't be getting any decimals, we'll be getting an integer part of the quotient only. So that we will get rid of the last digit. That's why we do n equal to n by 10, and then we will repeat the loop until n's value becomes 0. And once the loop is finished, in some variable we will be having the sum of the prime digits of the given n. So let's try with an example. So here I'm using the variable name as num instead of n. Okay, so num is equal to input and sum is initialized to 0. So num's value is 1729 and sum is equal to 0. Now we check if num is greater than 0, which is true. 1729 is greater than 0. So we execute the body. So x is equal to num mod 10, that's 9. And if x is equal to 2 or 3 or 5 or 7, so x is not equal to any of those, so we don't execute the body of the if statement. And so we divide num by 10, so it becomes 172. It was 1729. When it divided by 10, it becomes 172. And then we check again, 172 greater than 0, and that's true again. So we put x is equal to num mod 10, so x becomes 2, and x is equal to 2, so that's true. So we'll be executing the body of the if statement. So sum is equal to 0 plus 2, so sum becomes 2 now. And we divide num with 10 again, so it becomes 17. And 17 greater than 0, that's true. So we execute the body again. X is equal to num mod 10, that's 7. And 7 is equal to 7, so that's true. So we execute this again. Sum is equal to sum plus x, so sum equal to 2 plus 7, that becomes 9. So num equal to num by 10, so 17 by 10 equal to 1, and that's true again. Then we take the last digit of that again, so but it is not equal to any of those prime numbers, so we don't add it. And num equal to num by 10, that's 1 by 10 equal to 0, and that is false. So we exit the loop, and in the print statement we'll be printing the sum, because sum is the variable will be having the sum of all the prime digits. So this is the algorithm. Now let's try to implement this using code. Okay, so we will be using Python this time to execute the code. So the input format is the first line of input contains integer t denoting the number of test cases, and the next t lines contains integer n. So first we need to take t as the input. So int of input. Then we need to loop t times. So for that we use for I range 0 to t. And for each test case there's an integer n. So we take that also. N equal to int of input. And for each value of n we need a sum variable to calculate the sum. So sum equal to 0. And while n greater than 0, we need to do something. We need x is equal to int modulus n mod 10. So x will be having the last digit value, and we need to check if x is equal to 2, or x is equal to 3, or x is equal to 5, or x is equal to 7. So these are the 4 prime digits, only 4 prime digits. So if that's true, we need to add sum equal to sum plus x. We add the x value to the sum, and after that we need to reduce n, right? We need to get rid of the last digit. So n equal to n by 10. So this makes for example, if it was 1729, it becomes 172, like that. So after each after the execution we need to print the sum. Print sum. So that's all. Now let's try the sample test case. Yeah, sample test case passed. The sample test case was 333, and that's answer is 9 and 686. None of them are prime, so it's 0. Now let's submit the code. Yeah, it's accepted. So I hope the answer and solution was clear. In case you all have any doubts, please do ask, and we will try to provide this code in GitHub or somewhere. Thank you for watching.